So we got your package units, the geothermal water furnace package units. The water goes into here, and if you have a superheater on it going to the water heater, they tie into here. This is a complete package unit. There's nothing else to it besides the loop, wherever it goes. But somebody asked me about ambient air temperature and superheat and subcooling. So I wanted to make this quick video and show him. He was asking if the ambient air temperature, or what does the unit usually run head pressure on entering, or outdoor ambient air temperature of, say, 70, 75 degrees. He wanted to know what the head pressure and what roundabouts would be the superheat and subcooling. So I found the parameters, which is in the installation manual. This is just for the Envision units. This isn't for the new Series 5 and Series 7, but I have that as well. But basically, your entering water temperature is the same thing as your entering air temperature, or your ambient air temperature to your condenser. Because if you're in cooling mode, then your geothermal loop is basically your condenser. So you would relate that in air-to-air terms as 70-degree entering water would be the same thing as 70-degree outdoor ambient air temperature. So to answer that question on that, you can pause this to look at it or whatever, but you go across here, and the water flow rate is the speed, the gallons per minute, that goes through the unit. And typically you want 1.5 gallons a minute going through the unit in an open loop system, and 3 gallons a minute per ton. That is, I'm sorry, 3 gallons a minute per ton. So if you have a 3-ton unit, you want 9 gallons a minute. And that would be the same thing in an air-to-air situation as having a variable speed fan on top of the condenser. Because that would, I know some of them units out there, their condenser fan will speed up and slow down according to head pressure, especially for low ambient cooling. Alright, but anyway, the discharge pressure, if you were on a closed loop system, this would be open loop, 1.5 gallons per ton, and closed loop. So your suction pressure would be running right about there. Your head pressure. Typically, closed loop is what we work on, but if you ever get the open loop, these are the discharge pressures you would probably be seeing. Your superheat, no matter what, either way, 10 to 16. And that's at entering water temperature, which, like I said, was the same thing as ambient outdoor air temperature on an outdoor air-to-air condenser. This should be your water temperature rise. And then in cooling mode, them units do 17 to 23 degrees. So I hope that helps. That was a little bit on that. This is the second stage operation. There's differences a little bit in the first stage because these are dual capacity units in this chart. So I'll give you a second to look at them. This is cooling up here. I might have been giving you the heating one, but yeah, this is cooling. He wanted to know what it was in AC because he's from South Carolina. So 70-degree entering air, which is our entering water, will give you pressures around 250 to 280, not even 300. Superheat 10 to 16, subcooling 8 to 14. 7 to 13 degree water temperature rise, and air temperature drop across your evaporator coil, 17 to 23. And the heating mode is usually a little bit better, 22, 28, 24, 30. Because in the cooling mode, you're getting rid of the heat of compression, so you can't do as good at cooling. And then if you have a single speed unit, which is over here, you can kind of look and see what you get. Entering water 70, or in your case, air to air, entering air temperature, ambient air temperature, 3 gallons a minute per ton, suction pressure, 250 to 270. So this is cooling without a desuperheater. Hot water generator is the desuperheater, which just takes water from the top of your water heater, your hot water heater tank, puts it into the bottom. After it goes through the unit, it adds about 8 to 15 degrees of heat to it when the unit can do it without taking any efficiency away from the heating or cooling demand. So that's your single speed unit, dual capacity unit, superheat, subcooling, and all that. And then your second stage. You can, like I said, entering air, or ambient air, just like entering water. Speed of that is just like your condenser fan, because that's the speed of the water going through the circles in the coax coil, absorbing heat or dissipating heat into the water with refrigerant lines wrapped around it, real skinny ones. So that's it on that one. That's the Envisions. That's the spec catalog right there. That gives you all your heat of extractions, heat of rejections. So that would be the one I'd be looking for. Let me zoom out here. That's the one I'd be looking for if I was trying to get my heat of extraction and heat of rejection tables. So you go flipping through here, and you can see you got a ND 038 dual capacity unit, and that is high speed, so that'd be second stage. And then it's got, first thing you want to get is your water pressure drop and your entering water temperature. So usually typically is 60-70. So then you would put your pressure gauge in on this chart, water pressure drop PSI, and say you got 70 degree water and you got a 3-pound pressure drop. You come over here, this column, the second column there is your GPMs, gallons flow rate. Entering water temperature drops and drops as it goes down. And then there you go. So you got 9 gallons per minute at entering water temperature of 70. So you put that 9 gallons a minute down, because that's one of your factors you're going to use in getting your formula. Then you get the leaving water temperature, and you subtract the 2. And that is your delta T across your water coil. Temperature difference. Then you plug that into 500 if you're not using antifreeze in the system. And it's, so it would be 9 gallons a minute times 500 times, let's say 9. And then you multiply that. That would be 45,000 BTUs. And depending on the size unit, you would come over here to your heating or your cooling. You want heat of rejection or heat of extraction. So if you pan out a little bit here, and you know you're in the 70s, you bring this line around, and if you're looking for cooling, it said 45,000 BTUs. We come over here, this one is circled, third column in, back from the back, or from the right, sorry. You follow that column down, and we were at 45, just with a quick estimate. And that's roughly how you get that. Same thing for the heat of extraction. Use the same formula, you just plug in the different numbers. And you can see that would be around 35,000 BTUs heat of extraction. This one will be about 49,000 BTUs heat of rejection. And there's books on all of them. I mean, it's got all the information. I got this book when I was in water furnace school. And then they give you this quick reference guide here that you can probably pause on and study a minute. It tells you all the possibilities, high or low head pressure, and it'll tell you what the problem. High water flow, and cooling. Man, the water flow is going too fast. Indoor air temperature, say you just fire one up and it's 30 degrees in the house, you're going to have a low head pressure, low suction pressure, low compressor amp draw, normal superheat, high subcooling. So this is like a quick reference guide. If you come across something and you go do your chart and you fill out your sheet, then you can check this. And there's another one of those sheets. I always print a bunch off to try and leave them with the units. All right, well, I hope that helps. Thanks for watching.